this video, I want to talk about how we can simplify some natural base expressions. So in the previous video that I did on my channel, the one that I just uploaded, talks about what is the natural base e. So I'll link that video in the cards right now if you want to go and check that out, just so you have an understanding of what in the world this e is doing on the screen right now. Okay, so for these natural base expressions, it's very similar, evaluating them is very similar to some exponent rules or the properties of exponents that we talked about in Algebra 1, a little bit in Algebra 2 as well. So I'll link the video that I've done on properties of exponents just so you can review that in the description of this video if you want to check that out. So for number 1, I see e squared times e to the 9th. So the way I teach this is a little acronym called MADS. MADS means multiply, add, divide, subtract. So if we have a multiplication problem, like we have here on number 1, and the bases are the same, here the base is e, then we can keep the base and we can just add the exponent. So this would just be e to the 11th. Okay, so now what I'm going to do is I'm going to bring my calculator on the screen, and we can see how we can use our calculator here just to verify this result. So the button that we're going to be focusing on here on our calculator is the ln button, but notice when we hit second ln, we see e to the power come up here. So that's kind of the function or the button that we're going to use on our calculator. So we started off with e squared, and then we had times e to the 9th, right? So we hit enter and we get this decimal 59,874.14172. And we just said that that is supposed to be equal to e to the 11th. So if we type in second ln and we type in 11, when we hit enter, we should get the same decimal, and we do, right? So that tells us that e to the 11th is in fact equal to e squared times e to the 9th. So we've done that correctly, okay? Let's take a look at number 2. 25e to the 13th divided by 5e to the 12th. So kind of the same property rule here that I talked about MADS. Now we have division problem, so we can subtract our exponents. So we can divide our constants. 29 divided by 5 would be 5. And then e to the 13th divided by e to the 12th, we would just subtract 13 minus 12, and we would just get e, right? So our answer would just be 5e here. So once again, if we check this, we could do 25. Let's do e to the 13th. And I guess we can go ahead and put that in parentheses just so we make sure our calculator doesn't make an error here. So let's go second, insert a parenthesis there. Okay. So now let's divide this by 5e to the 12th. Close our parentheses, we hit enter. Okay. So we get 13.591, so on and so forth. And now we're saying that should be equal just to 5e. And now notice that the button that we've been using is e to a power. So technically we could use this and just let x be 1 because e to the first would just be e. But also another button on your calculator that gives you just e would be the division button once we hit second. So if we do second and division, we hit 5e, we hit enter, and notice we do in fact get the same decimal. So we are good for number 2. Now notice for number 3 we have an x also as part of our expression. So we're not going to be able to use the calculator on this one to verify it, but we can make sure we rely on our exponent rules to make sure we get this correct. So what we see here is we have 2e raised to the negative 3x power, and then also that property, or excuse me, that product is raised to a power. So I'm going to basically, distribute, if you will, or give this exponent to both these parts. So we have 2 to the 5th times e to the negative 3x to the 5th. So 2 to the 5th I know is 32. And now here we're going to multiply these two exponents. So this would be e to the negative 15x power. And now a negative exponent rule, essentially what we can do is if we have a negative exponent in the numerator, which is what we would have here, we can just bump that down to the denominator and it will become positive. So essentially we can leave 32 in the numerator and we bump down e to the 15x in the denominator, and that comes out as positive 15x as our power instead of negative 15x, right? And if we know anything about exponents, we really do not want to leave a negative exponent as part of our answer. So that is a necessary step in order for us to fully simplify that expression, okay? And that's how you can simplify some natural base expressions.